We are very pleased today to receive Professor Russell Thompson from University of Melbourne. Professor Thompson is extremely well known in the domain of city logistics, engaged in several projects throughout 2 decades, very much involved with the International Conference on City Logistics and books related to it, and he's very much involved in Melbourne and across Australia in city logistics. And he's here today to share his recent research on what he's been doing in the field related to city logistics, and the topic that I like very much, okay, which is the physical internet. So it's fun to see the other side of the planet is beginning to move. So without any further ado, okay, we'll have Professor Thompson. He's going to have a talk that's going to last like 30-40 minutes around this, and the rest we'll prepare to entertain questions as much as possible. So feel free, we want all these seminars to be very interactive. But we'll let him present, keep your questions, and then we go and run. Okay? Thank you.
Thank you very much. Thanks very much, Bernard, and thank you for the invitation to present here this afternoon. It's a great opportunity. I've wanted to visit here for some time, but this is my first visit, so I'm very excited about the work that's going on here. I've had a brief introduction, and it's outstanding. And I'd just like to introduce today some of the concepts of city logistics, which I've been involved in for about 20 years, in fact, and also more recently the physical internet and how we can enhance city logistics by incorporating the concepts of the physical internet. So what I'll do is I'll provide a brief overview of both city logistics and the physical internet, and then talk about some modelling work that I'm involved in and some future directions which I believe as young researchers, most of the people in the room here look like very young, eager researchers, some exciting opportunities that we've got in this area. Okay. Let me say. Okay, doesn't seem to be moving. Sorry, Benno. Okay, we're getting some out. Okay, first of all, city logistics. I'll talk about that. Then I'll talk about the physical internet, as I said, and then looking at how we can model these systems to try and understand more about how they could work, the benefits associated with them, and certainly how we design is not trivial. First of all, city logistics. City logistics, we defined this about 15 or so years ago as an area where we're looking at urban freight, but we're looking at broader perspective. We're looking at the total costs. We quite often focus on the financial or the operational costs associated with logistics and freight in our cities, but we want to look at the broader costs. We know that there are lots of social, environmental costs associated with the way that freight moves in and around our cities. So to bring this into a framework where we're looking at the trade-offs, looking at the interactions, but looking at the total costs, and particularly the way that freight has lots of benefits, but actually contributes to lots of the impacts that we as people, through noise, emissions, through safety, we find that this actually has a huge impact on our cities. So not always benefits, but freight actually does introduce lots of disbenefits, and we want to do this within the market or the economy. We want to do this within the economics. So we want a free market. We want a competitive industry. One of the easy reactions of government is actually to start introducing regulations, mandating certain behaviour, which can actually be counterproductive, can actually lead to more inefficiencies and, in fact, sometimes higher impacts. So we want the efficiencies of industry, we want the private sector, the innovation, the competitive nature of industry to still operate, but to actually incorporate and to be trying to lower those impacts, and as overall society we can win. And we can get these win-win-win solutions where communities, industry and the environment can actually gain from this. The OECD also looked at this about 15 years ago. In fact, this is a common problem. Cities around the world are suffering from the impacts of freight, and we need to look at these total costs. We need to look at the noise levels. We need to look at the environmental emissions levels, as I mentioned, safety, and build these into solutions to make our cities work better for the way freight moves around. One of the major recommendations of this international study was to say, well, how can consolidation levels be increased? A lot of our e-commerce, a lot of our just-in-time freight, in fact, it happens with vehicles with very small loads with respect to their capacity. So we have lots of trucks, lots of vans running around, but lots of capacity which is underutilised. So how can we rationalise the movement by introducing concepts which can increase that consolidation, the available capacity to be fully utilised, and how can we actually introduce ways of innovating within an industry which has typically not been at the forefront of adoption of advanced technology or new ideas. So how can we do this? So this international study started saying, well, how can we embrace consolidation as a key aim and also innovation? So we talk about city logistics as a very broad framework. So we're focusing on how cities can actually function better. And the pillars, or the green vertical lines there, represent the way our cities should function. The principles that are accepted in terms of the things that we all enjoy, that we all like to do, the way our city should be really functioning. We should be sustainable. So we want good air, clean air. We want low impacts of crashes. We want the environment to be nice, but also economic sustainability. The way our cities actually function as economic areas, and so to be sustainable also means that we've got to have a vibrant economy. Mobility, the ability of getting around, the ability to be able to move around our cities. As our cities become more congested, more freight movements can actually lead to less mobility, less ease of moving around, and this actually is undesirable, because what we want to do is we want our cities to be maximising opportunities for activities, for business, and this can actually be counterproductive with freight. Livability. And Melbourne, I think for the last 10 years in the world, we've been ranked as the most livable city in the world. And so we have very high levels of livability. So things like air quality, things like housing, things like education are very high on the, and how can freight enhance that? So we've got to look at how these pillars can be enhanced or preserved in terms of freight not impacting on them, but actually making them better. And the horizontal, we call them braces, are really some of the issues that freight actually has to contend with. Urban freight, urban logistics has many impacts, many different factors that we need to consider. We need to think about the economy. We've got security being a very major issue in our societies today. So freight actually does have a lot to do with this security. We've got to have efficiency, environmental, congestion are a problem as cities grow very fast. So in Sydney and Melbourne and Australia, we've got massive growth. Congestion's becoming a real issue. Freight's contributing somewhat to that. How can freight actually address these important problems? And we know that trucks and vans are bigger in size, and therefore the impacts of crashes that freight vehicles are involved in are usually more severe. So they're real issues that freight needs to contend with. The perspective of city logistics is a multi-stakeholder approach. We don't just focus on the carriers, which is the obvious way that we understand a little bit about the system. We see those trucks and vans moving. But here we need to focus on a number of key actors or players that in fact have a legitimate role, and they interact with the other players. And so these are sets or groups of common actors that are involved in urban freight. And the ones, as said, the ones that we normally associate freight with are the carriers, the trucks, the vehicles, the drivers. But we know that there are the shippers, the ones that are sending the freight, actually producing or distributing their goods in the city, their warehouses, from their production facilities. They are sending the goods, but also the receivers. These might be other enterprises, but it could be wholesalers, a lot of retailers, a lot of retailing done in cities. So receivers are very important because they get the goods and they are actually the customer for most of our carriers. But then we are all living in cities, urban areas more and more. In the global sense, this is the most popular type of area to live in. So residents, we all like to wake up to the sound of birds and not truck noise. We all like to wake up and see clean. We like to see the blue sky. In a lot of cities, unfortunately, that's not the case. So we've got air quality issues, we've got noise impacts of residents wanting to live and enjoy our cities. And the final one are the administrators, the public sector, who are trying to balance all this to try and actually make sure that they facilitate economic growth, minimise those impacts, make sure safety and performance of logistics systems are actually acceptable levels. So City Logistics tries to encapsulate all of these actors and their interactions and tries to look for solutions where we can get gains for all these major stakeholder groups to come up with very better ways of urban logistics. And each of these major actors or stakeholders have some common goals that we can assume, and that drives their behaviour, that actually dictates the way they tend to operate. And so we need to understand those because they will have different objectives, different aims and goals. And that is very important to consider because they're not all going to be playing the same tune. They're looking at different ways of measuring their performance and the different goals. So shippers will be, of course, interested in getting their stuff to their destination reliably, cheaply, and minimising delays. Carriers, more interested in operational costs, the travel times, the utilisation of their assets, their drivers, their resources. Residents, as I said, very interested in the living environment, the way that the environment is actually in the cities. Receivers, of course, they want the stuff so it can be sold. They don't want it all at once. So they're going to look at inventory trade-offs between deliveries. They're looking at how reliability, punctuality, and their deliveries can be encapsulated within their businesses to service their customers as well. And administrators really trying to look at how that can be balanced and that the impacts minimised, but also the economic benefits of freight can be maximised. So the physical internet. Benoit came to our international conference, I think about 3 years ago, introduced the concept, and it's a very exciting concept. It involves trying to fully integrate the way goods movement happens within cities, particularly cities, but I know it's a broader concept than cities, but particularly what I'm focusing on is how we can apply this in urban areas. So fully coordinated. So at the moment we've got lots of problems to do with compatibility, lots of delays, lots of problems to do with integrating our networks between modes, between those different stakeholders, and of course we're interested in sustainability. How can that be enhanced? And so with the physical internet, it actually describes some physical characteristics of the freight system or logistics systems. The containers, the nodes and the movers are the main elements of this system. And basically that what we're trying to do is look at global sustainability by looking at the way these physical processes can be integrated to minimise the total cost. So very compatible with city logistics, and that's what I really want to talk about today. And the concept of hyper-connected city logistics is to really say how can the physical internet enhance, achieve those goals of city logistics by looking at networks and compatibility at different levels within that urban area. So this diagram was introduced, as I said, to our conference about 3 years ago, and it tries to look at networks of hubs and exchange opportunities, to look at sectors where densities and different levels of nodes, where exchange opportunities for goods, different links where different types of freight vehicles can be servicing certain links and nodes, but doing this in an integrated way. We know our cities, the densities, the structure can change, the types of vehicles that are useful or efficient in certain elements of the network will change. We've got certain gateways. And so this is a very powerful concept to try and say, how can we structure our physical distribution systems and logistics systems to get that compatibility, because we know that this is a very complex system with so many different types of vehicles, so many different exchange opportunities, so many different types of goods moving around. How can this be done in a very integrated way? So conceptually, it looks easy and trivial, but of course we're talking about cities which are quite complex and with different transport, different links, different logistics facilities. So firstly, the movers. These are the vehicles, of course, that actually undertake the physical distribution or movement of freight. And so it's very important to try and identify the best vehicles for certain links connecting these transfer points or exchange points, and to look at what are the best vehicles to do this, and to get the most efficiency, to try and look at how these can be consolidated to get those levels of service productivity levels that we need. In Australia, we have very large trucks, and this is an example of our B-triple 3 trailers, and this operates on some of our urban freeways. And so this gives us some opportunities to have high capacity in terms of linking some factories and warehouses and getting very high levels of productivity because of the way that the driver and the vehicle costs are reduced for the loads that it covers. Very high levels of consolidation are necessary to get that efficiency, but this is a very large vehicle that operates in Melbourne. We're also looking at innovations in vehicle platooning, which allows vehicles to actually be connected to each other and to be following each other and automating without driverless. Following vehicles are typically driverless, very small headways, again to get that productivity. But this is some way off in the future, particularly in urban environments, but I think in the rural environments now they're testing and trialling these types of technologies, which will allow a lot more compatibility because of the way these vehicles can be connected to reduce the costs and operating. And then finally, we have quite a bit of interest in rail, even in urban areas, and to try and look at opportunities, because the environmental costs are lower, the operational costs are lower typically, but there's lots of issues about how we can actually connect these and at the rail heads and how the handling of larger vehicles. But in terms of transport efficiencies, of course, urban rail is good, but quite difficult to actually get very efficient networks because of the high flows that are necessary to achieve that, but also very high infrastructure costs. So the nodes themselves, these of course are the transfer points. These are the opportunities for reconsolidating, transferring loads onto different types of vehicles to get that compatibility that we need to ensure we've got the right levels of service, the right levels of consolidation. So, of course, what we're saying is that there's quite a bit of interest in what we call urban consolidation centres, which are special facilities set up to receive goods and reconsolidate these into vehicles which can either service the local areas or be exchanged off to other regional areas within cities. And so this is an advanced concept. Some cities have implemented these, but also we have different types of nodes or terminals which are cross-docking. So for the physical internet to actually make sense and actually work, we need opportunities to transfer goods between vehicles, to reconfigure the vehicles, to get the consolidation required, and this requires specialised facilities which are very efficient at transferring loads between vehicles and short-term storage. And two tiers can be established of those types of networks. Container loading is also very important. How we utilise the actual physical space on vehicles, how the boxes, the pallets, the different way we organise our freight can be exchanged, starts to think about how we can configure the physical space on our containers, on our trucks, to get those efficiencies and productivities that we need. So these are very interesting problems, bin packing problems, how we can combine different types and sizes and weights to achieve this compatibility, but also to get that level of consolidation. And so very practical issues come into play because of the way that our freight is not all the same size, it's not all the same weight, it's got different types of packaging, and we have different types of vehicles. And how can we design efficient routing systems to allow the order and the type of goods to be actually efficiently moved around our city? Very interesting problems. And then cross-docking, of course, is the exchange of goods between vehicles at terminals where they short-term get transferred between vehicles. And this is a very important facility. And to actually do this efficiently requires a network to be developed, different levels of decisions. We find in logistics that we need strategic levels, we need the long-term planning of these facilities, then we need the design of them, and then they need to be operated. So there's different types of decisions, there's different types of models necessary to make sure that these networks are actually going to be integrated and introduce those efficiency gains that we talked about. And so again, lots of practical issues. The real world is very complicated. We're going to be interested in things like reliability, but of course exchange requires coordination and synchronization of loads. So things like punctuality, delays can be very important. And also we know a lot of our freight now, we don't just want it one day or in a week. We actually like to nominate. A lot of people want it within the hour or small time intervals. So this gets very complicated in terms of how we can exchange these goods. So first of all, trying to understand how we can design collaborative urban freight distribution networks. Okay, so the concept is that most of freight and most logistics is actually done by individual companies trying to optimize their networks, their resources, and this is very common. So if we look at a hypothetical network within an urban area, we might have these small dots which represent customer locations, and we might have each customer being serviced by a small number of suppliers. In this case, a very simple one, 5 suppliers distributed throughout the metropolitan area. So how can we design a system that each supplier would normally service each customer, but how can we introduce a more integrated approach where collaboration could minimise the number of truck movements, the distance travelled by those vehicles? And so this is called code loading or collaborative freight systems, where shippers and carriers can actually start to collaborate to reduce their number of movements and to try and reduce those overall costs. So typically what happens is that, say from one supplier will service a sector or a region for one day perhaps throughout the week to service their customers. And this would be done for each of those suppliers, but typically trying to get efficient routes within zones or sectors of a city. To actually introduce a collaborative network introduces the concept of exchanges between suppliers and a hub supplier nominated for exchanging, in this case, goods. So the initial the way this network would work is in fact the vehicles from each supplier would service a central hub, exchange the goods, return to their warehouse or their depot, and then do some local distribution routes. And so conceptually, this is intuitively going to be far more efficient and less freight costs, and that's the way it is. So we actually we introduced a model to try and formalise this, to actually try and estimate the benefits for different types of products, different demand levels, and more complex networks. So I'll skip over the maths, but there's been modelling done where we've actually introduced optimisation models to try and look at the way that we can choose initially where that exchange is going to occur, and then how can we actually optimise the routes for vehicles between these supplier hubs and also the local distribution routes. And so we introduced some variables there. The formulation, the objective function is that in transport, we're going to focus on the transport costs. There is the transfer routes. That's the routes that the trucks are actually performing to transfer their goods between these supplier locations. And then, of course, we've got the local distribution routes that is that final stage of actually servicing those customers. So in a mathematical programming sense, the first decision is what supplier will become the hub of exchange. In this case, we'll only have one supplier where the transfers occur. Then we've got, of course, look at vehicle capacity, but in terms of these transfer routes, because each vehicle will have only certain finite capacity for that. And then we've also got to monitor the inventory levels, because we can't distribute it locally if we haven't got it in that local warehouse. So we've got to make sure the right goods get to the right suppliers in time to service those final customers. So we've got to monitor inventory levels at those locations. And then also we've got to make sure that our customers do get service within timeframes that are nominated, so they will have certain demands. And then we've also got to know that those final local routes are optimal and efficient, and so they've got to be determined as well. So, and of course, the actual customer demand has been serviced. So, also practical problems of length of driver shifts in terms of time and distance. Drivers can't drive for 24 hours a day, and so we've got to make sure that these routes actually have got some limits in terms of the distance travelled to make sure that the regulations in terms of driving hours are also satisfied. And so in Melbourne we did some study with real retail outlets, and so Melbourne's a larger city, and these are the locations around the city for a large retail hardware store chain, and 5 suppliers, which are the triangles there. And so usually what happens that each supplier would be satisfying around 48 customers here on a weekly cycle of distribution. And so we tried to look at how we could optimize this by nominating an exchange hub where the suppliers would transfer their goods at this point, and suppliers would be allocated a precinct or a zone to do their local distribution within, but with other suppliers' goods. And so we're able to achieve massive savings in terms of distance travel, around 78%. So by introducing that network of exchanges, and then, because Melbourne is a large city, maybe we're talking about maybe 50 kilometres across and maybe 60 kilometres north-south. So those distances between retailers, but between some of these suppliers is considerable. And so by comparing the distance travelled with standard optimisation for each supplier doing their own local distribution routes, and comparing that with our exchange model, we get massive savings in terms of distance travel, which will mean less impacts, less operating costs, and overall much better performance. We've been doing some surveys of retailers within our central business district in Melbourne. It's growing very fast, congestion levels are getting high, and so what I want to do is start to think about the receivers, actually what their costs are. In terms of deliveries, we've done some surveys recently, and we know that we wanted to get some information about how many deliveries they're getting, what types of deliveries, what timing, and the frequency of those. And so this data is not generally available very easily because it's commercial, it's sensitive data. We're able to get over 200 respondents from shops and establishments in the CBD, and we're able to do a stated preference survey to look at what sort of new types of services they would prefer or be willing to accept if there was change in terms of a consolidated receiving. And so we put up some options using stated preference in terms of looking at what sort of time windows they might prefer, what types of new services which could be introduced from a more consolidated delivery regime, and then looking at what sort of information they might like in terms of the timing, particularly, of these deliveries. And so we're able to do this using stated preference to understand the different factors that receivers in this case would be preferring in terms of new services which could be achieved with this more consolidated level. And so we did over 200 establishments, and we did quite a broad cross-section of different types of retailers to try and look at if there was variation within these different broad types of products that are being sold and stores that are actually receiving them. And so we're able to look at the preference levels for different types of, and this is willing to participate in the general consolidated deliveries, more rationalised, mixed deliveries, getting deliveries from multiple suppliers, but not so many of them per day. And we found that this, of course, varies between different types of sub-industries in terms of retailing. And we were able to find that certain sectors were more and more acceptable and more preferring this type of delivery, and we're able to look at their preferences overall. We're able to also look at where they're located, because it's important to know that within these areas, to get that efficiency, to get that consolidation, there is a spatial aspect to the distribution as well. And we're able to sort of look at, again, what were they really wanting? What were they really desiring from these new types of delivery systems? And of course, nominating a time window is very, very popular. Also, new services like reverse logistics, like the ability to be able to actually have some inventory close by in case they needed emergency. They're very interested in reducing their number of daily deliveries. And also they'd like to know more about when the actual goods are coming, so they can plan their receival and their staff to get that efficiency. And so again, this coming through, there's certain preferences for nominated times, some extra services in terms of unpacking and waste removal, and temporary storage were seen as very desirable. And so these new systems really have to be aligned to the receiver's preferences for different types of services that could be provided, different levels of service that could be provided. And so we also found that it was quite interesting to us that some companies are receiving an awful amount of deliveries every day. And this consumes valuable resources that really takes them away from their core activity, which is actually retailing and selling stuff, to actually backroom types of jobs, receiving, sorting, unpacking. And so you can see that the distribution of the number of deliveries per day, some are getting well over 8 deliveries, and a significant number of them getting more than 5 deliveries per day. And so this actually is an extra cost for retailing to process this, and a lot of it happens ad hoc. It's not planned, it just happens, and this introduces lots of extra costs. The network effect. Now, in economics, the concept of networks is that as we get more users of networks, we get higher levels of efficiency. And this is actually counterintuitive to a lot of our traffic engineering, which says the more users, typically our levels of service go down. But in a network sense, the actual more users we get, that means the more benefits that we actually potentially have. And this works well with shared networks, which is a physical internet concept of actually sharing the way that our networks operate. And so as we start to share, independent companies sharing resources, sharing nodes, sharing vehicles, we've seen that in fact we get lots of potential for gains in efficiencies. And value increases as we get more users, because typically we get more nodes and we get more links. And so we get higher levels of service for potential customers. And so, of course, looking at the way that some of these other industries have been able to incorporate this network effect. Qantas and American Airlines. Now, Qantas back in the 1980s realised that they could get people to the West Coast in California very easily, a line haul type of movement. But when they got to the West Coast, they found out the Aussies wanted to go, lots of different places, and it was very inefficiency to provide those types of services. So it made a partnership with American Airlines. It was one of the first code-sharing operations and led to lots of efficiencies, because actually by sharing Qantas passengers going on American Airlines gave us Aussies lots of destinations at a reasonably cheap price with no extra operational costs for Qantas, but they got all the benefits of accessing all these other cities in the US. And so this is very successful, and now most airlines actually use this code sharing arrangement and it works very well. The other one is ATMs, very commercial, accessing your money, trying to get your money out. A long time ago it was back to you had to go to your bank or you have to pay huge fees. But now we've got this integration. compatibility, integration. You can go to a machine and you can withdraw money, you can get money because these networks are being shared. And so the costs have lowered for everyone, and we all enjoy access to our money at locations where we might not have our bank, which is great. Very interested in how we can adopt the concepts from public transport. Public transport systems have been evolving for centuries. How it can actually provide personal transport in open, connected networks without us having to use our own vehicles. And so the way these networks have developed is that there's a hierarchy of lines, hierarchy of links, very similar to the physical internet concept, that there's different levels, and this provides different levels of service for passengers, opportunities to choose different levels of frequency with very high capacity in some links and lower capacity in others. So basically this involves having to have interchanges. People got to get on and off to access these different types of services, and some of them can be express, some of them can be hub type of exchange to different lines, but gives us lots of opportunities. And of course pricing, that the way these networks are priced, time of day and priority for different types of services is a common way that public transport services are priced to allow these networks to offer levels of service that are desired. And so one of the concepts is how can we apply these public transport concepts to logistics, urban logistics, and actually with the physical internet as a framework, how can we encapsulate some of these concepts to get those increased efficiencies. So the business concept, we need to think about in logistics that this is a financial business for lots of organisations. So we have to think about financial viability. So the shared networks, we really need to start to understand what the extra costs will be for certain players, what the cost savings will be for other players, and do this on a life cycle, because they'll be investing in facilities, investing in vehicles over an extended time period. And in fact, we need to start to understand that businesses, the way that they price, the way that they cost these different assets are very important to build into our models. And so we need to firstly think about how we can determine the gains, the cost savings that can be achieved by organisations by sharing their vehicles, sharing their terminals, and sometimes even sharing their customers. So this is a very important part of our models, to estimate what are these cost savings and to identify these for different players in these networks. We also need to say, how can we form partnerships? These are highly competitive industries, highly competitive organisations, and as we've seen with the airlines industries, they're actually sharing. They're sharing their planes, they're sharing their customers. How can we do this in freight? Everyone says, oh, it's too sensitive, everyone's commercial and things like that. There are some challenges, but we've seen in other industries that this has been achieved quite successfully. And then also, how can we use models to understand these different competitive strategies, the different ways that the business reacts to different ways of organising. Game theory, we're doing work on game theory at the moment to try and understand how we can use that as a modelling approach to show that there are different strategies, there are different types of decisions, and there are winners and losers, and there are different gains to be made by different types and size of companies, different types of, as they share their networks, we need to understand the response of business to that. And also agent-based modelling allows us to model the interactions, the communication, the dynamic time elements of these networks can be encapsulated and combined with optimisation to start to understand how these networks can evolve, how they can actually work with different types of decision makers. And so we've been looking at the very simple transport models, but of course we need to start to understand more about inventory and handling costs, and to build these into these more traffic or transport models. We'd also need to be very much aware of how we can understand the contracts that occur between the shippers, the carriers, the receivers. Who has power, what are the performance levels, what are the way that they're priced and costed. And this is quite sensitive information, so it's very hard sometimes to get this information, but very important if we're going to start to change these networks. And then how can we start to understand the benefits for receivers? Quite often they will have power within the supply chain, but how can we understand what are their benefits? As we saw with the retailers, predictability, knowing more about the timing and having rationalised deliveries can actually lead to significant benefits for them. But how do we quantify these and build these into our models? And so we need to also understand how we can allocate these cost savings across the network to various players that are getting some benefit, and how do we appropriate and allocate those savings, of course. And so we need to look for fair allocation rules based on usage, based on the cost savings, but of course we need to understand that sometimes this will disadvantage some certain players, and some approaches such as proportional and marginal cost allocation need to be explored, because there will be different impacts for different types of carriers, for different types of users. And so we also need to understand the attitudes of these various stakeholders, because some of them are very insecure and certainly will resist sometimes this. There's a lot of resistance to sharing, and as information needs to be shared, as actual loads and things like security, reliability, and liability of that is a very important concept there too. And also we need to work on the algorithm side. How can we develop more efficient algorithms? These are very, very complex models, and so we need to work on how can we get very good solutions, how can exact solutions be developed or applied, solution methods be applied to make sure that we can actually get reliable, consistent, optimized networks to work with. So thank you very much. I'm very happy for some questions, and thank you very much for your attention.
So, Professor, companies such as Amazon that have a monopoly over the transportation and shipping right now, why would they like to join this concept? They would lose the monopoly, right? In the end, it's all about making a business, profit, industries.
That's a very good question, because a lot of, in the city logistics paradigm, as well as I think the physical internet, the larger organisations that are already heavily invested in their infrastructure, their warehousing, their vehicle fleets and their systems, you say, well, why should they actually open their network or actually allow that to be provided? I think what we're finding in our inner cities is that some of the way that e-commerce is taking off, even those large providers are making it's very difficult for them. So even though they maybe have a competitive advantage, they're still getting very high costs to deliver individual parcels to individual households or enterprises, and small lots, small loads, and so they're in some respects losing money in certain elements of their network. They're making it at others, maybe volume, at certain links they're making money, but when it gets down to that last 100 metres or 50 feet or even the last kilometre, they're finding it very hard as well. And they're having to subcontract, they're having to look for it more consolidated. So there's still, I believe, benefits for larger organisations who in certain elements of their network will find it very difficult and to get that price, to get that price difference. And so even large organisations now are coming to us and saying, how can we look for a more open, consolidated model, integrated model, because we're finding it very difficult to get the drivers, we're finding it very difficult to make money, it's very frustrating. If we can do this in a more coordinated way, more integrated way, then we believe that we can save money and still have the levels of service. But as I said, there's initial resistance, I think, for these large organisations who see this as unnecessary. But as our congestion levels rise, as e-commerce becomes so much more prevalent, even those companies are going to find it very difficult to make money in these sort of markets.
Just to follow up on that, sorry. Follow up on that question. For a large company like Amazon, is it more attractive on the inbound side, in other words, supplying their warehouses? I mean, there still could be opportunities for them to consolidate on the inbound side rather than on the distribution side.
Look, I think it's certain elements of the networks we're really we're still early days for this collaboration and consolidation, and I think that it's very variable on the networks, but certain elements of the networks that we really need to analyse, and that they will be hurting, and they, I believe, will actually have some potential for cost savings. So certainly we're finding in the inner core areas of our cities, even the large players are struggling even to make money. They're losing lots of money, but they're able to cross-subsidise with efficiencies gains in the larger, broader, regional networks. So I think it really starts to understand that we really need to start to analyse networks in sort of the different elements of those networks, and looking at where the efficiencies are, where the cost-saving potential is. And I think that, yeah, certainly what we've found is that last kilometre inner area is one where there's common recognition of that there are savings by collaboration, and to do this is a sensible thing, and certainly willing to explore that. And I think these models and these sort of solutions, physical internet orientated solutions, can be part of that solution.
Do you think there might be an opportunity in goods like pharmaceuticals and fresh products which need a specific temperature control environment in transit? Because as far as my experience in my own country, Pakistan, what used to happen was that there were different pharmaceutical companies sending in products to the retailers, and they were not using the complete truckload. But they were still, because they had to use the temperature controlled truck, they were using it for their transit. So do you think there's an opportunity there?
I think there's lots of challenges to do with the way goods are packaged and temperature controlled and sensitive types of goods. I think that's a challenge, but we've seen it even in some of our vehicles. We can have segment vehicles. You can actually have vehicles that have got refrigerated components and in cool environments, and then dry goods. So we can actually see some smart solutions actually in the vehicle. Storage also, I believe. I don't think these problems are really unsolvable. I think that it's really starting to say, well, yeah, we appreciate that there's a diversity of different types of goods, that perishable goods, for example, that need temperature control, food goods, but I believe that will be able to be solved with necessary infrastructure, and again with a network effect. The more users, the more viable these will become. So basically they're not being used so much at the moment because the facilities don't exist so much, but as as our perceptions change and the paradigms change, I think these facilities will actually be able to be sustained and viable. It's just, again, sort of getting that network effect, so the more users will actually create more benefits for everyone.
Yes. Professor, so I really agree with how sensitive is the data and how competitive is the market is, and I think that this kind of city logistics needs really big support from government. Can you tell me more what is like the government action, like Australian government action in supporting this, and do they have to make some kind of policy or something to make this happen?
The role of government is very important, but it's quite complicated. Governments don't really have the expertise and the actual resources and infrastructure typically, apart from, say, some public road networks and other infrastructure. So the role of government really has changed to be more of a facilitator, so actually trying to facilitate this, trying to look at regulation that actually is not actually going to be counter productive, but actually look at ways of giving some incentives to, because government has got a good role in the way that they manage the infrastructure, the way that they price the infrastructure, the way they allow access to infrastructure. So governments sometimes react very, very quickly and put up all sorts of regulations when they see, sort of bad effects or negative behaviour or high impacts. But it's actually working with industry and to try and partnership with industry to try and look at how they can facilitate better practice, and actually they innovate and not be a barrier. So it's a different way of thinking, because quite often government think of regulations and all sorts of barriers, but actually they really starting to work a lot closer with industry and starting to understand their needs and starting to see how they can provide solutions which can make and lower those impacts. Of course, they've got to be very careful of not siding with certain companies and certain sectors, so it's a very delicate But really, I think the best models are partnership models, where they can actually start to work with industry, gain some knowledge, start to understand how they can manage their infrastructure better, price their infrastructure better, to get better levels, better types of behaviour.
Hey, we may have time for one last. Okay, you've got it.
So I had two questions, but I'll ask only one.
Okay.
So you talked about temporary storage. So
Yes.
what do you really mean by it? Is it like a mobile warehouse? Can it be used for probably using the potential that remains unused in empty trailers or things like that?
It could be, but I think what's happening with these urban consolidation centres is that they provide a bit of a buffer, and it's quite often very close to the receiver. So this allows emergency stock and some sort of off-site inventory. So these urban consolidation centres are usually quite close to the retail precincts, quite close to the stores, and they can provide a backup, emergency, and actually can provide a service instead of actually having to order extra freight and extra truck trips, but shorter ones. So they can provide short-term storage. And quite often in our inner city areas, the inventory costs are very high because of the land values. So this provides an extra benefit, really, for allowing that sort of reliable stock to be actually, some of it pre-positioned reasonably close. And so that is what becoming sort of recognised as actually a benefit of these urban consolidation centres. And so it's more, that they provide an opportunity to have some storage reasonably close, and so they can quickly and without having to incur the extra costs, but also the delays of having to access, stock when it becomes unavailable from a large distance away.
On this, I'd like to thank Professor Thompson for a very stimulating presentation, an overview of city logistics and physical internet into hyper-connected city logistics, focusing on these perception of challenges from a very pragmatic perspective, more modeling perspective, and fundamental conceptual issues. For those of you who are going to have classes more into this kind of domain, okay, with us, then this will be a lot of food for discussion, for thoughts, and etc. And overall, I think this kind of work, okay, is growing around the world, and Professor Thompson is among those who are really leading the way. So let's us thank him for his excellent job.
You're right.